Welcome back to another episode of Tidal Flooding Talk, brought to you by the New Jersey Coastal Coalition. It is a meteorologist only hosting show for today. We have meteorologist Dan Skeldon. I'm Joe Martucci. Dan, what's happening here? We both obviously got the memo that we were going to wear blue shirts for today. Hopefully, we're not feeling blue as well.
I'm not. We're kind of working my way a couple more weeks till Labor Day, and we're working out of your wheelhouse and favorite time of the year and into mine. So I'm excited for the fall. I mean, although this summer hasn't been that brutal. There's been some bad stretches, but we've had some hints of fall, some comfortably warm weather here or there. So I've been okay. But of course, you know me, when September arrives, I just get all excited, not feeling blue at all. How about you?
That's Dan's season. Yeah, I mean, and we haven't had much coastal flooding, which is good news, of course, being Tidal Flooding Talk. Yeah, we are recording this before I go on my first ever cruise, but it's airing when I get back. So I'm going to pretend that I went on the cruise already here. So I think if I was to say, I'm going to say the cruise was great. I didn't get seasick, and I ate all the food I could ever imagine and got to get extra tan in the tropical Caribbean sun.
I think that's a pretty good prediction. We should have had Palma do one of those before she went to Greece
We
and
should
predict how her trip went. But
That's true.
we'll be seeing
Yeah.
her. We'll ask her in person in a couple of weeks.
That's true. That's a good point. Good point. All right. Well, speaking of cruise, today's topic, ocean heat waves. Cruise ships are on the ocean, right? It might be tempting to jump in the ocean with how warm the water is in some stretches. But for today, we have a great guest. We're looking forward to chatting with her. We have Mari Bif. She is an associate professor at the Rosenstiel, hopefully I got that right, School of Marine, Atmospheric, and Earth Science at the University of Miami in Florida, where it is also tropical waters throughout the year. Big cruise ship area as well. And by the way, this is our second guest from the University of Miami just this year. Back in February, we had Eric Michel from the Rosenstiel School. So, Mary, welcome to the show. No pressure. We're going to see who has the better show, though, between you and Eric. We'll see.
Oh my God, okay. I need to meet him after the show then. I need to have him hear my recording after that.
So I'm guessing that the school within the University of Miami must be pretty big if you guys don't know each other. Is that correct?
It is. It's one of the biggest marine institutes, at least for the marine side. I think he's atmospheric side, right?
Yes,
and it's a pretty big university and school, about 1,200 people here in our campus in the middle of an island. So
Gotcha.
beautiful keys here.
And you're from Brazil, but you're obviously school here in Miami. So you just couldn't get out of the tropics. You had to stay in the tropics, just different hemisphere.
Miami pulled me. I came here for a PhD about 11 years ago, and I left. I lived in California for 6 years. I worked at the Monterey Bay Aquarium Research Institute in Monterey, and it was too cold. It was way too cold for me. So I had to come back to Miami. Yes.
Okay. Yeah.
Here is paradise.
Damn.
Now, air temperature too cold, water temperature too cold, or both in California?
Everything is too cold. It's too constant. My problem with, Bay Area and Central California is that the weather is too constant, which for some people is paradise, right? And for me, it was hell because I needed the sun and I needed the heat, which Miami gives me. But California is too pleasant. It's too constant.
We should ask where in California too, because San Francisco and Los Angeles are in San Diego
so Monterey area, Monterey, Santa Cruz. Yeah.
Yep.
Well, remember was it Mark Twain who said this? The coldest he's ever been is the summer in San Francisco.
I don't doubt it. I wouldn't doubt it. Yes. Yes.
All right.
We call.
Cool. See, we like to have a little bit of fun here on Tidal Flooding Talk. I'm sorry, Mary. Go ahead.
Yeah. No, it's so foggy that we call August Fogust.
Fog.
So it's the peak of the summer, but it's just fog.
Yeah, you don't have that problem in Miami, so that's good.
No fog in Miami at all.
No, beautiful. Cold in Miami is like 70. You know, it's
Yes,
not,
yes.
not a bad gig, right? All right. So, keeping with the heat theme, let's talk about some of the research that you did. So we actually came across you, like we do for a lot of episodes, actually, by just reading stuff on the internet. And that's what we did. I have to preface, it wasn't even me who read this. It was Dr. Bill Thomas, who is our kind of our number 2 at the New Jersey Coastal Coalition. He said, "Hey, Joe, maybe you want to reach out to Mari about the headline that is how a monster ocean heat wave could fuel a super El Nino." So let's start with, we'll do a little bit of explaining. El Nino is part of the El Nino Southern Oscillation, which is how above or below average are water temperatures in the equatorial Pacific Ocean off the coast of South America, extending to an area south of Hawaii. Long story short. So when it's warmer than average, it's El Nino. When it's colder than average, we're in La Nina. Right now, we are and it doesn't matter that we're recording this a little bit before the 18th of August. We're in an increasingly strong, El Nino. And we have the possibility for a record El Nino going into this winter. So I kind of like what was here at the beginning. The chance of an El Nino event emerging by July, this of course was written a few months ago, is now over 80%. At the same time, though, an exceptionally large 9,000-mile marine heat wave has been forming in the North Pacific since the end of 2025. I think a question some people might have is, wait, we can have heat waves in the ocean? So let's just start there, right? What is that? What defines a heat wave in an ocean?
Yeah, so heat wave in the ocean, which we call marine heat wave, is very similar to heat waves that happen on land. And actually, a land heat wave can be also a marine heat wave, right? If it happens in an area that is large enough, you could have, a marine and a land heat wave happening in the same area. So a marine heat wave is a heat wave when the ocean also exceeds a certain temperature threshold. So similar to El Nino is kind of a type of marine heat wave. It's just a heat wave that develops on a very timed every few years, right? So marine heat waves can happen everywhere, anywhere in the ocean, in a region where you see these exceeding temperatures going above, we say 0.5 degrees more than the average, and then sustaining for a few weeks or a few months and sometimes for a few years. So similar to, high temperatures on land, the ocean is going to have higher temperatures too. Very similar mechanism, similar formation. It's just that it happens in the ocean rather than in land. And then the ocean is going to store that heat differently than the land, right? Because we are talking about ocean versus soil versus land.
And Mari, you say 0.5 degrees. You mean Celsius, right? Which, listeners might be thinking, wow, 0.5 degrees, that's not much. But number one, it's Celsius. So that translates to more in Fahrenheit. And number two, you want to explain how oceans, respond slower than land to warming and cooling. So while 0.5 degrees Celsius doesn't really sound like much at first glance, really it can be fairly significant.
It is very significant. And another point that I want to make is that we talk about Celsius because in oceanography, we work with Celsius and metric system. So it's never feet, it's never Fahrenheit, it's Celsius, it's meters. We deal a lot with depth, right? Because the ocean is deep and we want to understand what is in the water column. So we are always dealing with meters as well.
Great. We're going to take our first break and we'll dive more into this topic in just a minute here on Tidal Flooding. Base flood elevation is the level floodwaters are expected to reach in a major storm. Building below it puts your home at risk. Building just 1 foot above it can significantly lower flood insurance costs and reduce flood damage. And don't forget to elevate mechanical equipment like air conditioners and generators. Small changes can make a big difference. This message is brought to you by the New Jersey Coastal Coalition. Did you know your community's flood risk can affect your wallet? Even if you don't live near the water, flooding can happen almost anywhere. That's why many towns participate in FEMA's Community Rating System, or CRS. And that includes a lot of our towns in the New Jersey Coastal Coalition. By improving flood safety, planning ahead, and educating residents, communities can earn discounts up to 45% off of National Flood Insurance Program premiums here. And we have 2 towns in the New Jersey Coastal Coalition that get 35% off, one of the highest in the country. Ask your local officials if your town participates and learn what you can do to protect your home and family. You can visit FEMA.gov/CRS to learn more. All right, we're back here with Mari. We're talking about ocean heat waves here and talking about the research you had about this heat wave. So let's explore, let's get into this heat wave in the North Pacific. You said it started at the end of 2025, 9,000 miles long. I mean, put that in perspective for people. Is that big for a heat wave? Is that about what we see in the Pacific? Like, where does that kind of rank?
Yes, it's huge. It's huge, the area that encompasses, right? It encompasses the equator, it encompasses the tropics, and even to the subtropics. So, big range of latitudes. And it looks very surface, but we are not really sure how this is going to develop. And one thing that us scientists do, at least the oceanographers, is that it takes a little bit for us to really analyze the data from the ocean and then come up with a formation and persistence of this phenomena, right? So we are not really sure what formed and how it's going to persist yet. It's still in the works because it's still happening.
Mari, I mean, we know weather stations on land, some go back 50 years, some go back 100, a little bit more than that. What's the data, the historical data like in the oceans? Obviously the oceans cover much more of the earth, and there's obviously no weather stations. There's buoys and that out there. But, how much of a record do we have to compare with what's happening now, and how good is the data you have now? Because the Pacific, obviously, biggest ocean on earth.
Yeah, so this is my favorite part of oceanography, is dealing with big data sets. We have an ocean observing system. So the way we observe the ocean is through different platforms. So we have the equivalent of weather stations that are buoys in ocean. These weather stations, they're called moorings, and they are everywhere in all of the oceans. In the equator is very important because of the El Nino. So we have a bunch of these moorings that collect meteorological and oceanographic data. Temperature and salinity is the bare bones of oceanography for us to understand, is ocean warming? Is the water becoming more dense or more light? How is mixing going to affect the temperatures? So we work a lot with density, which is really a function of temperature and salinity. We also have different platforms that help us understand the ocean. These moorings, they have been in the ocean for decades and decades and decades, and we have a very good historical data set. But to have the spatial coverage, right? Remember, imagine if you have one mooring, which is one line full of sensors, it's going to measure only that area of the ocean. So to increase the coverage, we rely on other types of platforms and sensors. We rely a lot on satellites. So satellites that skim through the ocean surface, measuring temperature and other properties. They give us a very good understanding of what is happening at the surface. So when the El Nino, those warm waters propagate through the equator, the satellite can capture that. And we have other platforms. My favorite are the Argo floats and the biogeochemical Argo floats, which are robots that we throw in the ocean, and they stay there for years and years, drifting with ocean currents and profiling the ocean and collecting data far from the surface up to 2,000 meters. We have some robots that collect up to 4,000 meters of depth.
Wow.
And the biogeochemical Argo floats are equipped with chemical sensors. So not only you can take a look at, the effect of the marine heat waves, the El Ninos, but you can look at the nutrients, you can look at phytoplankton, you can look at particles, pH, ocean acidity. So they're all drifting. We collect all of this data. We put together like a soup and then we make sense of the ocean. So it's a lot of data science going on. Similar to meteorology. We are not as funded as meteorology, but we do something similar for the ocean. Yeah.
Yeah. You said you're not as funded as meteorology?
Yeah, we don't have as many observations as meteorology has for the ocean.
Okay, I thought you meant funded because I was like, Dan has a nice pool in his backyard. He's doing just fine. Over there in the meteorology world. So all right, so let's talk about what we have going on. So when you talk about this kind of heat wave here that we have going on in the Pacific, when people think about heat wave, typically on the East Coast, most of our listeners are on the East Coast. They're thinking about hurricane season and the lack of a hurricane season that's been forecasted, and as of the time recording, really has played out. It's been very quiet in the Atlantic. So, is there something you can say about that heat wave in the North Pacific and how that relates to hurricane season in the Atlantic? Are they related? And if they are, how are they related?
Yeah, so we know that hurricane seasons are strongly related to El Nino and La Nina conditions. We don't really know the effect of marine heat waves on that. Studying marine heat waves is a little bit of a more recent science. Now that we have enough coverage of the ocean, spatial coverage of the ocean, is that we start understanding, these marine heat waves, they happen everywhere, not only here, not only there, in the Southern Ocean, in the North Atlantic Ocean, in the subpolar gyres, right, in the high latitudes. So now we start understanding and just trying to explain what are the connections, right? But if you think that there are some connections with marine heat waves and El Niños, then you would imagine that maybe marine heat waves would also affect the hurricane seasons. But yes, during El Nino, we have usually quieter hurricane season. And
Mari, in addition to its effect on hurricane season, plus or minus, whether it enhances it or shuts it down, what is the effect of a marine heat wave on the ocean itself, on the ecosystem, on everything that's going on at and below the surface of the ocean?
Yeah, to me, this is what I am most curious about. And that's why I started learning a little bit more about the physics and formation and persistence of these marine heat waves, because I am interested on the effect of carbon cycle. So how much carbon is the ocean going to be trapping if we have these marine heat waves that are more frequent or feeding an El Nino? What is going to happen with the ecosystem with a feedback on the carbon that the ocean can carry? So we learned from previous marine heat waves in the Pacific Ocean, in the North Pacific Ocean, that it really disturbed the ecosystem. We had a marine heat wave. The first one that was very well documented was called the Blob, and affected the Gulf of Alaska from 2013 to 2015. And then we had the Blob 2.0 from 2019 to 2020. And those marine heat waves brought a lot of harmful algae blooms to the coast. So toxins, very deleterious for human health and for the ecosystem health. We had shifts in species. So different species were not growing, phytoplankton, fisheries were not growing in certain regions because of these marine heat waves. We had migration of fisheries to other areas because they just couldn't handle those high temperatures. We had mass mortalities of birds. There was the highest mass mortality of bird ever recorded in history due to that 2013-2015 blob. We have a decrease in oxygen in the ocean, and that's very bad, right? We have a lot of organisms breathing. And because those waters are so warm and they they prevent circulation, they prevent the oxygen to get in the ocean, and also, waters that are warm itself are a problem. But we have a lot of different effects. We have cascading effects through the entire food web. And I imagine that these new marine heat wave that is covering even a larger portion than the Blob 1.0 and 2.0 are also going to have consequences. Even though this marine heat wave is in another area, those consequences are going to be felt for sure.
Awesome. All right. We're going to take our final break, and then we're going to get into some more here about ocean heat waves, and including this upcoming El Nino on Tidal. Thanks to the New Jersey Coastal Coalition, your flood insurance bills are lower and your streets safer from the reality of flooding. Since beginning in 2013, we build more resilient shoreline communities. Our member towns develop and share in best practices that anticipate future concerns and create flooding solutions. From our town-specific free web app for flooding information to our weekly tidal flooding talk show, we focus on flooding 24/7. Visit www.njcoastalcoalition.com for more. Flooding.
Well, welcome back to this week's Tidal Flooding Talk with meteorologist Joe Martucci and myself. We're talking heat waves and not the traditional stuff we normally talk about in August. Mari, on land, heat waves are measured in days, right? 3 days is a short heat wave, 10 days is a long heat wave. Everything is different in the oceans, how quickly or slowly it warms up and slows down. And, everything being different in the ocean, and we talked about it in the last segment, I get the sense that ocean heat waves aren't a matter of days. They can be months, they can be years. Is that traditionally what we look at in terms of ocean heat waves? Everything is slower and longer when it comes to our oceans.
Yes, the ocean, the water takes a little bit longer to warm it up and lose heat. And well, that blob 1.0 that I just mentioned, it lasted for about 2 years, which was actually fed by an El Nino. So one fed the other. It was the one marine heat wave causing, problems, causing an effect in the atmosphere, and the atmosphere in the North Pacific Ocean going toward the equator and causing an effect in the El Nino, and then going back up and feeding the blob. So
And
2
Mari,
years.
I'm sorry. Go ahead. Well,
No,
I
2
was going to
years
say,
of persistence. Mm-hmm.
who names these heat waves? We call tropical storms like Arthur. You guys come up with blob. I love it. I mean, it's just more catchy, more.
Yes, I will tell you that the blob 1.0 and 2.0 were the only marine heat waves that I know that were ever named. I think it was named by a scientist at NOAA, the National Ocean and Atmospheric Administration, when he first observed, and it looked like a blob in the ocean, right? Like a warm circle. So, and it was giant. So he was surprised and called it a blob. But we should start naming all of the marine heat waves now that they are so frequent.
Should.
And I mean, this one is almost lasting a year. So we'll need to see if it's going to keep going or if it's going to fade.
Okay. What in terms of this year's upcoming El Nino and the winter ahead? I mean, one thing we're kind of keeping an eye on is, with the increased, with this El Nino, it's either going to be very strong or a record El Nino, an increased risk of tidal flooding here on the East Coast. Can you link that in any way to increase coastal flooding risk or more sea level rise than usual? What can you say anything about that?
I don't think so. I don't think it could be maybe connected to sea level rise, but sea level rise is not only ocean temperatures rising, right? There's a lot of sea ice melt and things like this. But it will increase the overall temperature of the planet for the year, right? So this year and next year, when we budget how warm the oceans are getting and how warm the planet is getting, we are taking into consideration the entire globe. And if we have that giant marine heat wave, that is going to add up to the temperatures, right? To record of temperatures.
Yeah, one of the theories among climatologists is like, okay, climate change, the Earth is warming, and it would be warming even more if the oceans weren't absorbing all this heat. So the fact that we're studying this, and I love the robots that are out there. I think that's so cool. Such a great technological feat, just roaming the Pacific, constantly taking measurements all the way down to, what you say, 4,000 meters deep?
Most of them 2,000 meters. We have some new ones that go down to 4,000 meters. Because one thing is measuring a point in the ocean, right? But we don't want to be biased by location. We kind of want to measure how the ocean is warming and freshening everywhere. So then we can make a very good estimate, right? So these robots really give us this opportunity to cover as much as possible of the world's ocean.
Absolutely. And like they call it NOAA for a reason, right? Because oceanic and atmospheric, I mean, the two sciences are so intertwined. And I think this just is another illustration of that.
Yes, they are very, even though sometimes we don't talk too much I feel like the atmospheric scientists don't talk too much with the oceanographers, but we should, because the ocean and atmosphere interactions is what makes climate, right?
Yeah, 100%. There's more in the ocean than there is of the land, right? So that's for sure. All right. Well, hey, thank you so much for coming on. We're not done yet. We have the one thing we can't stop talking about, tidal flooding or otherwise. But tell us where we can follow more of the work that you're doing here on this topic.
Oh my God, I am a horrible advertiser for my science, actually. I am on LinkedIn and I am on, ResearchGate and all of the old school things that boring people do. I write articles occasionally, like I wrote for the Bulletin of Atomic Scientists. The reason why I wrote this article is because I wrote an article about the blob. And then the editor reached out to me and said, "Hey, Mari, there is another one. Write something to us." But I write here and there. Not a lot of outreach. I should do way more. My lab has a website, but it's super small. Yes, I would say Google my name and see what comes up.
All right, Google me. I like that. Google me. See what happens. All right, we're going to get into the one thing here, and we'll start off with Dan. Dan, I did foreshadow yours, but I don't want you to take it if you don't want to. But go ahead.
Oh, no, I just ironically, a quick story. In late July, there was a meteorological feature. I started seeing the word nor'easter on social media, a word that we all associate with coastal storms and snow and all the stuff Mari hates, right? It's nothing tropical about a nor'easter. It's tidal flooding and wind. And I'm just saying, why is this word being dug up? I texted Joe, just say, "Hey, I got a great thing for the one thing we can't stop talking about." And it turns out Joe was one of the people who used the word nor'easter. I had no clue at all that I'm calling out Joe and complaining about Joe without knowing I'm complaining about Joe. But I guess that would be the one thing I can't stop talking.
All right. Well, I'm gonna use my time to talk about Dan here. So you're like, he's not wrong. Like on a few, like I think there's room for everybody to hang their hat on something here. But yes, I mean, in New Jersey, where we are based out of, we did not have northeasterly winds. It was a mini coastal storm, but we didn't have the northeasterly winds that define a nor'easter. But there were northeasterly winds in southeast Massachusetts and in Dan's home state of Rhode Island at the same time. From a public messaging standpoint, Dan is 100% right. When we think nor'easters, people are thinking rounds of tidal flooding, significant snow or rain or wind. And, significant rain we did have, but we didn't have the tidal flooding. We didn't have the winds. I said it was a mini nor'easter. I made very sure to say it was a mini nor'easter. It was not a big nor'easter. It's what.
And Joe, I will give it, if from a New England perspective, it couldn't qualify. I did check the winds when the storm, like, it wasn't like a deepening big low pressure or anything along the coast, but it might be borderline qualifying in New England. So I think you said it right. I think the cases can be made. Everyone can hang their hats on something. Yeah. So.
I don't have any. There is no animosity towards you, Dan. With
absolutely not
that one thing. So anyway, Mari, it's up to you. I mean, I don't know if you probably don't want to talk about nor'easters, but what's going on? What's going on in your world outside of the oceanography, marine sciences world?
Well, New Jersey is in my agenda for Friday, actually.
We love that. We love that.
Yeah.
So something that I can't stop talking about is paddling. So I am going on a paddling race that is going to start in New Jersey, and we are going through the Hudson River and paddle 12 miles around the Statue of the Liberty. So I do, outrigger canoeing, and we are leaving Friday morning from Miami, and I'm representing Miami in my club. And on Saturday, we're going to have a beautiful race. So I have been practicing and training a lot this summer to get ready for that. So yes, I have been talking a bunch, and my friends cannot stand anymore.
Well, the Statue of Liberty is beautiful, of course. I can't say I've never really interacted with the Hudson River water. I've been on it on like a ferry, but I've never been that close to the Hudson River water. So I'm curious to see your thoughts. We'll have to have you on and see how the race goes.
Yes, I heard that it's pretty strong. I heard that you should not touch the water if you can, because it's not the cleanest.
I agree. I don't think I'd be touching the water. I definitely wouldn't be drinking it. Let's put it that way.
Yeah, and I heard it's a little bit of a wild ride. It's a challenging race, especially where the ocean meets the river. Lots of waves. But our canoes are, the type of this canoe is actually to withstand wind and waves and really surf the waves. So it's gonna be
Awesome.
super cool, super amazing views.
Great. All right.
Well,
Awesome.
wishing you great luck in the race. That's awesome.
Yes.
Thank you.
Yes. And enjoy your time in the area.
Thank you.
All right. Well, for Mari, Dan, I'm Joe. This is our Tidal Flooding Talk show. Like and subscribe. We are on Apple Podcasts. We are on Audible. We are on YouTube. You can find it on Dan's Facebook page, my Facebook page, the New Jersey Coastal Coalition social media channels. There's a lot of ways to find us, and we want you to be involved. If you have an idea for a topic, let us know. You can reach out to any of us on our social media channels. We'll definitely take that into consideration. Till then, everyone, we'll talk to you next week, and take care, everybody. Good talking to you.
Bye.